started without recording, so I'll just go back for a second. So this one is our parent graph, right here, and I've graphed it. And our reference point is 1 away from each of the asymptotes, 1 away from each of the asymptotes, and the graph never touches the asymptote. That's what guides the graph, or the function, I should say. This one, in contrast, has a horizontal shift. When I solve for x minus 5 equal to 0, I get x equals 5. So I know it's going to be a horizontal shift to the right by 5. So I'm going to draw that asymptote over 1, 2, 3, 4, 5. So my graph is shifting over 5. And this right here tells me my vertical shift. But notice there's no x with it, right? So there is no solving for 0 on that one, correct? So it's just moving up 7. This one is to the right 5. So when I go ahead and map out my asymptote for this, it's going to be shifted up, not here, but up 1, 2, 3, 4, 5, 6, 7. So this whole graph right here, my parent graph, is going to shift itself. Let's see if I can do some whiteboard magic here. So I've got that one and that one, and it's going to do this. It's going to shift over here, right? It's going to shift over here. So it shifted to the, and then it shifted up, and then that 1/4 in front of it is going to change the shape of it. So it's going to shift, and then it's going to change shape. I wish I hadn't used 1/4. Let's change it. We can change it, right? We have the power to do that. What? So you have to write what twice? I'm just comparing and contrasting the two graphs. Okay? No. So I'm going to go ahead and I'm going to cover this up. One more second. It should be white. There we go. I'm going to cover this up and I'm going to change it to a 3. Let's make it a 2. Does anybody know why I'm changing it? It's easier to graph, right? A 1/4 is a lot harder to graph. All right, so when I'm here, this is now my origin, my new origin after I have shifted, right? So instead of off of this asymptote, and I start 1 away, I can't go up 2 on the asymptote because then I'd be touching the asymptote, right? We can't be touching the asymptote. So we have to move 1 away, and now we're going to go up 2, right? And off of this asymptote, I can't go over 2 here because I would be on the asymptote, so I better go up 1 first, and then I'm going to go over 2. So from each side, I'm going up 2, and from here I'm going over 2. Okay? So there's that one. If it was 1/4, I would have gone over 1 and up a 4th, but I didn't want to graph that when I'm trying to make this an example. So I'm going to go over 1, down 2, down 1, over 2. So over, down, over, down. Okay. All right, what if I put a negative out front up here? What would that do? Let's use a better word than flip. It's going to reflect, exactly, across the y-axis, right? It's going to reflect. This one right here would end up in the 2nd quadrant, and this one right here would end up in the 4th quadrant. All right, good. So there's a review of what we did on Monday. Let's practice. Whiteboards. guys should have the green sheet protector whiteboards. Also, those will be easier to graph on, unless you have a whiteboard that has a graph on it. Then you're good. All right, let's graph one. Okay. There you go. All right, let's graph x minus 5. 1 over x minus 5. Show me that. Show me. I'm going to pause it. Okay, so we're at about 90%. So the first thing I need to do is I need to plot my asymptotes. So I'm going to shift to the right 5. 1, 2, 3, 4, 5. I'm not going to shift on the y at all because there's nothing out here. My a, right, if we looked at this as f of x equals, this is my standard form, a over x minus my horizontal shift plus my vertical shift. So there is no vertical shift, and my a, there's nothing out in front of here, so it's not a 0, because 0 times anything is 0, it's a 1. So from here, from my new origin, I'm going to go over 1, and then from this asymptote, I'm going to go up 1. Over off this one, I'm going to go over 1 and over 1. Same reference point, that's what yours should have looked like. Right? Let's see if I have another one of these. I don't. So I'm going to duplicate this slide and erase all of this. Alrighty. Let's try. We'll duplicate this slide just one more time, just in case we need it again. Alright, so this time I'd like you to do that. I think you guys can handle 2 steps. It's a horizontal shift and a vertical shift. We just talked about this. We just talked about what this says. This is the. It's like the slope, right? It's the stretch. It's a stretch of the graph. I'm gonna pause it. 1. So I think what we're struggling with, Bryce, is that some of you are only plotting one reference point. So we've got to work on that. Okay? So let's do our shift first. So this one is a horizontal shift, right, boys? In the negative direction. So I'm going to go 1, 2, 3, 4 in the negative direction. You guys all have that good. Then this one is a vertical shift. So it's going to, you guys, I need you to stop talking, please. Thank you. So here, I'm going to go a vertical shift up 2. And this A right here means I'm going to stretch my graph by 3. Maybe this will help. Let's try this. This just came to me. So normally I would be over 1, up 1, right? But instead of going up 1, I'm going to go up 3. Right? So that's in this direction, but see, you can't mess this up, because instead of going from here, you're not going to go up 3, you're only going to go up 2, because you already went up 1. Does that make sense? So this would be a normal slope of 1. I don't want a normal slope of 1. I want a slope of 1, 2, 3. Does that make sense? Better, Trinity? Okay. So now I've got one going up, right? So now I need one going out. Okay? So you have to have 2 reference points. Because this is a stretch from this asymptote, it's stretched right? Instead of just going up 1, it stretched up 3. Now from this asymptote, normally it's 1, right here. But instead of being 1, I'm going to stretch it out 1, 2, 3. Do you see how they're both stretched? Is that a little bit better? Okay. A lot bit better? Awesome. I'm glad we took the time to do this. Because I was seeing a lot of graphs that looked like this. It shouldn't be like this dip here. It should be stretched out, right? Kane. Then it's wrong. Yeah. You need 2 reference points. The only time you can only have 1 reference point is what? Yes, you're going to get credit. When do you only have 1 reference point? When it's this A is a 1, right? Because it's only stretching 1. So it's stretching the same in both directions, okay? All right, so there's my stretch on that one. So it looks like that. It's not graphed very well. And on this one, instead of being 1, it's going to be 1, 2, 3. And off of this one, instead of being 1, it's going to be 1, 2, 3. You still do what? Yeah. You guys, just instead of going, you say to yourself, over 1, up 1. But instead of going over 1, up 1, the second one you say, you multiply it by 3. Right? Alrighty. So that one's done. One more? Okay. Let's do cover this up. Show me that one. Pausing. I don't know what to say. I think we're about 75% right now. Okay, so let's look at this one more time. I think some of this tripped you up. There is no vertical stretch. I'm sorry, horizontal. There is no horizontal stretch. There's nothing there. It didn't move to the right or the left. Okay? There is none. So my asymptote is not going to shift right or left. It's going to stay right there. I'm getting horrible at doing that. Drawing a straight line. So it's going to stay right there. Does that make sense? It's not shifting. The only shift I have is a vertical shift. Here's my vertical shift. It's going to shift down. So it's going to shift down 2. You guys, I think 100% of you got the reference points correct. So my reference point means I'm going to, instead of going over 1, up 1, I'm going to go over 1, up 1, 2, 3, 4. And instead of going up 1 over 1, I'm going to go up 1 over 1, 2, 3, 4. So it's going to look like that. Let's do one more with a fraction. 1, 2, 3, 4. 1, 2, 3, 4. You could even put a little dot right here and go, oh, instead of 1, we're going to go 4. Instead of 1, we're going to go 4. Okay? But those are looking really good. I can't even draw an arrow. All right, I want to see 100% of you get this one right. So I duplicated the slide. Let's see it. Yeah, that's not right. How about just let's do it right? And so you can get a good grade on your test. Okay, so let's shift. Let's do x minus 4 and plus 1. And we're going to do a half. Okay, I'm going to pause. 2, 1, recording. So this is what I should have seen. It's looking really good. I think we're ready to shift. Get it? We're going to shift. So this means we're going to shift to the right 4. And this means we're going to shift up by 1. So I'm going to shift to the right 4, 1, 2, 3, 4, and I'm going to shift up 1, and instead of stretching, I'm going to compress. So instead of going over 1, up 1, I'm only going to go over 1, up a half. I'm going to cut it in half. And instead of going up 1, over 1, I'm going to cut it in half. So it should be half of my parent graph. Yeah, you just go up a half. That's what this number right here is telling me, right? It's telling me I'm going to stretch it. I'm not actually stretching now. I'm compressing. I'm making it smaller. Yes, Link. Yes. No, let's not do that right now. I changed my mind. Okay, next thing we're going to do. We're going to get there. Yes, we're going to get there. Right now, basically, guys, I'm really realizing that I'm assessing that you guys need some help on this, about 50% of you, okay? And I don't want to start beginning unit day wrong, right? We want to make sure you guys are solid with this, okay? So I'm going to take the time to do that, especially since it's a Wednesday, because what we got going on today, I don't want to rush it. All right, Emily, if you have your phone, you better put it away. All right, so I'm going to rewrite each function in this form right here. Hold on a second. I'm going to rewrite each one of these in this form. You need a 1 up in front, right there in the numerator. I need a 1 there. Is this a 1? No. So we're going to, let me do this more simply. Let's see. If I had 4x over 3, isn't that the same thing as, couldn't I pull that 4, 1 out? Isn't that the same thing as this? Right? What if I had it in reverse? What if I had 3 times y over 2? I could put a 1 over it and I could multiply straight across and I would have 3y over 2. So what I'm going to do is I'm going to do this in reverse. I'm going to go backwards. Okay? So let's do another one. If I had 4 times 1 over x, right? I could rewrite that as 4 over x. Correct? Because I just put a 1 underneath it and I multiply straight across. Michael? So if I had 5 over x, couldn't I rewrite it as 5 times 1 over x? Okay, that's what I'm going to do right now. Okay, it's the same thing. It just has more stuff. This just has more stuff, but it's the same process. Well, what about if it has number? Well, let's just wait and see. All right, so I'm going to do this process right here with this one here. Let me change it to purple. All right. So this 4 right here, I'm going to pull it out in front of my ratio. So I'm going to have a 2, because that's what's out here, plus, this is my ratio, right? That's my ratio. So I have a 2 plus my ratio. You guys should not be talking at all right now. I have a 2 plus my ratio, but instead of having a 4 on top, I'm going to pull that 4 out in front, and I'm going to be left with a 1 over x plus 2. We're almost there. So normally the a is in front. I have my horizontal shift here, and my vertical shift is in the back. Here is my vertical shift, right here, vertical shift, but this one happens to be in front. So the only thing I need to change now is the order of this. So I'm going to have a 4 in front times my ratio, and I'm going to put the 2 in the back. It's the same thing. I'm just moving stuff around, but it is the same thing. I have a ratio times 4. Isn't this like saying I have 4 of these? Could have rewritten it like this, 4 times 1 over x plus 2. And then reversed it, 4 over 1 times 1 over x plus 2. And then I just dropped the 1. Okay, I'm going to do one more, and then we're going to practice. Yes? Okay, I'm going to go quicker on this one. So this 3, I'm going to move it to the back. So I'm going to have a plus 3 in the back. The 2, I'm going to pull out in front. So I'm going to have a 2. I'm left with that 1 that I want in the numerator, x plus 2 plus 3. Now it's something you could graph. Now it's something that you guys recognize from what we've been doing, right? It's got a horizontal shift to the left, then it's got a vertical shift up, 3, and then it has a stretch of 2. All right, you guys ready? All right, whiteboard. Okay, I'm going to do this one. Okay? All right, I'm going to do this one, and then we'll do this one with whiteboard. Hold on. All right, so the only difference with this one is that this does not have an x minus h. We have a coefficient. We've got to pull that coefficient out. All right, so I'm going to say it's just like this. Let's do the same thing that we did with the other one. I'm going to show you something a little bit more simple, and we'll do something a little bit more hard. So if I had 1/2 times x over y, isn't that the same thing as x over 2y? Because I multiplied straight across. So couldn't I also do this? X over 3y equals x over y, and pull out the 1/3, pull it out. You see that? So that's all we're going to do. I still see confusion. Aren't these the same thing? It's just this one I'm going in this direction, I'm multiplying. This one I'm actually dividing it out or factoring it out. I'm pulling it out. One more? Simple thing like this? Okay, let's do it. All right, so if I had 1/3 times x squared over, we'll just say 2. 2 over x squared. If I multiply across, 1 times 2 is 2. And 3 times x squared is 3x squared. Now I'm going to do it in reverse. Let's say I had 4 over 5x squared. Couldn't I take 4/5 out and just put a 1 there? Why not? Why can't I take the 4/5 out? Isn't 4 times 1, 4, and 5 times x squared, 5x squared? It's just rewritten in a different way. Better? Kane. Couldn't I still pull the 2 out of the what? Because this is really 4 times 1. I could pull out a 2. This would be, then it would be this. If I pulled out a 2, it would be this. It is this. It's the same thing. You could pull out whatever you want, as long as when you re-multiply it, you get the same thing. Okay? Yeah, if you had this, right, and you multiply 2 times 2, you're going to get 4. And if you multiply 5 times x squared, you're going to get 5x squared. If you think you're doing it wrong, then once you pull it out, multiply it back in your head and make sure you still get the same thing. Okay? All right, so let's go to something a little bit more difficult. All right. So I'm going to do the first one. I'm going to go slow. I'm going to let's move the 1 in the back. Is that okay? Because that's the easy part, right? The 1 goes in the back. Then I have a 3 times x minus 3. I'm going to leave this negative 1 like it is, and I'm just going to factor out a 3. Does everybody agree that I just factored out that 3? And if I multiplied it back, 3 times x is 3x, and 3 times negative 1 is negative 3. So these are equivalent. Correct? Okay. So now I'm going to pull out not just a 1, but a negative 1. So I'm going to plot a negative 1. I'm going to pull out the 3. And I'm left with 1 over x minus 1 plus 1. Now I'm going to see if I did that correctly. If I take a negative and multiply negative 1 times 1, do I get negative 1? Yes. If I multiply a 3 times x minus 1, I get 3 times x minus 1. So it's the same. Want to try it? Okay. So first thing I want you to do on your whiteboard is I want you to rewrite it with the vertical shift in the back. Move the vertical shift first. That's all I want you to do on your whiteboard. Rewrite the function with the vertical shift in the back. What? We're only doing this. We are only moving this. That's it. That's all I want to see. Okay, you guys aren't listening. All I want is for you to move the vertical shift. That's all I want you to do. Only thing I want you to do. Let me see. Okay. Okay. All right. That looks really good. So you should have had this. You should have had 2 over 2x plus 2 plus 1. Now, the only thing I want you to do now is I want you to factor out the denominator. Just pull a 2 out of the denominator. That's all I want you to do. Not everybody is. I need to see the same thing on every whiteboard. Jean, all we're doing is factoring out this 2. All right, Nancy? Okay. I'm glad we did this step because we're not all getting the same thing. Okay, we're about 75%. 75%. Ready? In 5, 4, 3, 2, 1. This is what I saw some people do, and we're going to learn from our mistakes. I saw some people do this. Which technically is right. No, wait. No, I saw some of this. That's what I saw. Did you see a lot of x plus 2s? Okay. So we saw that, right? So what did they do with this one? They pulled a 2 out and decide to put it out in front. Isn't a 2 in the denominator a fraction? Right? this is not equal to this, right? You can't just take a 2 out. If I saw this, could you say, you know what I want to do with that 2? I'd like to just put it out front. They're not the same thing, right? This was another thing that I saw, or what Miss Liz said she saw. Correct? Miss Liz?
No, she said that this is wrong.
Yeah? Got it. Okay. Yeah. Or we saw, so that's pulling a 2 out, but if I were to re-multiply it back out, which is what you should be practicing, this would be this. 2 times x is 2x, and 2 times 2 is 4. Oops. Is that what we wanted? No, so you should always be going back and saying, does it make sense? What I factored out, what I distributed out, does it make sense? Okay, Mama, it's the end of the period, so tomorrow when you come in, just put your phone on my desk. All right. All right, so this is what I should have seen. All I wanted to do is factor out that 2. 2, when I factor out a 2, I get x plus 1. All right, that's all I should have seen. All right, the last thing we need to do, we need it in this form, right here. I need a 1 in the numerator, and I need no coefficient in front of that x. So if you've got anything in the numerator, you need to pull it out and keep it in the numerator. If you have anything in the denominator, you need to pull it out and keep it in the denominator, right? If it comes out of the denominator, it needs to stay in the denominator. If it comes out of the numerator, it needs to stay in the numerator. Ready? All right, let's see it. There's a 2 here, right? And there's a 2. I should have no coefficient in front of the x plus 1, and I should have nothing in the numerator but a 1. So you've got to factor it out. Almost. I'm so glad I did it like this, because we're not getting these 100%. You guys are almost there. All right, let's see. Okay? Okay, we are probably about 30% correct. Ready? Okay, so I am going to, right here, I'm going to factor out a 2. When I factor out a 2, I'm left with a 1. I'm going to stop. You guys, there shouldn't be any talking since 30% of you did it correctly. That means we're not okay to be talking. Okay? When I factor out a 2 here, I'm also going to be left with a times 1. So let me factor both of those out. It means I would have a 2 in the numerator, and I would have a 2 in the denominator. Correct? I pulled 1 out of the numerator, 1 out of the denominator, and I'm left with a 1, right? Left with a 1 in the numerator, and I'm left with an x plus 1 in the denominator. And some of you simplified it even more, because 2 over 2 is really 1. So really all I needed was this. Because a 1 times anything is just itself. Great day, you guys don't have any homework. We'll start here tomorrow, okay? Thank you. You're welcome.